Assalamualaikum and hi. Greeting to all the panels involved in this final year project 1. A big thank you to you all that is involved in the succession of this FYP1. I would like to express my gratitude to my supervisor, Professional Technologies, Dr. Idris Saad, for guiding me through the succession of FYP1 proposal. Other than that, I would like to thank you, Professional Technologist Dr. Zaino Helmi Solihin, that act as the coordinator for this FYP1 for helping and guiding us throughout the completion of FYP1. My name is Shafiq Afandi bin Sahruni and my student ID is 2019528161. My final year project title is as stated in the slide, which is heat recovery device to preheat higher viscous fuel for compression ignition engine, parametric optimization of number of rod fin. Project summary. Biofuel has been utilized for power production on diesel engines, commonly known as compression ignition engine, for several decades. Waste cooking oil, also known as WCO, has a great potential to be used as a primary source of biofuel generation in various types of biofuel. However, because to its high viscosity and density, it may reduce engine block performance when combusting with pressure air. This will result in inefficient engine combustion, reduced engine performance, and increased exhaust emission. Thus, in order to improve the characteristic of WCO, research was conducted to determine the number of rod fin type heat recovery device that collect heat from the exhaust and use it to warm the WCO before it is delivered to the engine. 5 models will be created dependent on the number of rod fin type heat recovery device used. The most effective arrangement model will be determined by the greatest WCO temperature flow out from the heat recovery device from the created 5 models. By preheating the WCO at a high temperature, its characteristic will improve the combustion process in the engine, resulting in improved performance and lower emission to the atmosphere. Introduction. Energy is one of the most important resources to each humankind. Globally, there is surge demand of energy sources due to intense growing of human population. The depletion of fossil fuel become a global concern. Therefore, biodiesel have grown more intriguing to many academics due to their biodegradability and sustainability as an alternative fuels. Due to the environmental effect of petroleum fuel diesel engines and the diminishing petroleum resources, biodiesel has emerged as a possible alternative to fossil fuel for diesel engines. Biodiesel can be produced from a renewable domestic resource, for instance waste cooking oil. Biodiesel may reduce both petroleum diesel consumption and this engine exhaust emission. It has been suggested as a viable replacement fuel for compression ignition engines. Next is biodiesel. Biodiesel is a type of fuel composed of monoalkyl esters of long-chain fatty acids produced from vegetable oils and animal fat. It can be utilized as a partial or whole replacement for fossil diesel fuel in compression ignition engine, for vehicle propulsion or energy generation. Biodiesel is the best candidate for diesel fuel in diesel engine. Biodiesel burns like petroleum diesel as it involves regulated pollutant. On the other hand, biodiesel probably has better efficiency than gasoline. Biodiesel also exhibits great potential for compression ignition engine. Diesel fuel can also be replaced by biodiesel made from vegetable oils. The use of waste cooking oil as diesel engine fuels offers the benefit of avoiding the energy, time, and expense associated with biodiesel manufacturing. Since waste cooking oil has a higher viscosity than mineral diesel, it must be treated to make its combustion characteristic closer to that of mineral diesel. In this study, a heat exchanger was utilized to reduce the viscosity of waste cooking oil by using waste heat from engine exhaust gas. World energy demand continued to rise. The most feasible way to meet this growing demand is by using alternative fuels. One such fuel that exhibits great potential is biofuel, in particular biodiesel. Heat recovery device. A heat absorption unit, a heat emission unit, and heat pipes comprise the new heat recovery device. A lot of effort has been done to recover the heat from compressors using an oil system, but few research have focused on the housing. The primary benefit of the heat recovery device is that it does not require additional energy consumption because it only driving force in the temperature differential between the compressor shell and the working fluid within the suction line. Heat exchangers are divided into several kinds based on their application. To choose the best heat transfer heat exchanger out of all the options, various adjustments to the heat exchanger surfaces should be made. The heat exchanger's fin tube is the finest option for extracting heat for the organic Rankine cycle. By using the shell and tube of heat exchanger, approximately 10 to 15% of heat is extracted, and the highest feasible quantity of heat extraction is around 3.6 kilowatt at full load. Problem identification. Energy is vital, and fossil fuels are one of the most important, but unfortunately, fossil fuels are become decreasing. Hence, researchers need to find alternative ways to replace fossil fuels. WCO, which is waste cooking oil, can be reused and produce energy. However, it has high in density and viscosity. Therefore, this study proposed a heat recovery device to reduce viscosity and density in the exhaust system by recovering waste heat due to the high viscosity, high density, and low calorific value of WCO biodiesel. This study recommends preheating the fuel mixture before sending it to the CI engine by building a heat exchanger to recover waste heat on the exhaust pipeline. The number of rod fins must be considered to increase the heat transfer between the liquid and increase the temperature. My objective for this project is to study the effectiveness of heat recovery device in improvising heat recovery rate by manipulating the number of rod fins. For my limitation of the project, due to the pandemic issue, the experimental-based investigation cannot be carried out. Thus, the analysis is done by using software simulation. Some of actual parameters are limited by the software, and the resulting finding will be preserved for future reference. Through ANSYS Fluent CFD software analysis, this study overcome quite difficult when the part of mesh optimization between the number of rod fins and the temperature. Methodology. As for the remedy to the stated issue, ANSYS Software Fluent was used to compare and monitor the temperature change throughout the HRD with varied numbers of rod fins. The table shown indicates the prior experimental setting and dimensions for the analysis and simulation to achieve a comparable outcomes. HRD, which is 54 mm diameter, exhaust 17 mm diameter, inlet and outlet of HRD 11 mm diameter, inlet and outlet exhaust 16 mm diameter. The process and method to be employed are critical to achieving the project's goal and obtaining the best outcomes from an experiment-based project. The creation of 5 distinct models is critical since it sets the project's objective. The methodology's core procedure is focused on model development, designing on 5 various number of rod fins, analysis, and comparison. The most effective model will be determined based on the greatest WCO temperature flow out of the heat recovery device from the 5 model developed. The figure below depicts the design of 5 distinct rod fin type heat recovery device. For the model 1, it contains 8 number of rod fin. For the model 2, 10 number of rod fin. Next, the model 3 contains 12 number of rod fin. And model 4, 16 number of rod fin. And the last one, model 5, it contains 20 number of rod fin. For the results, this is the base model for my project. I just use the base model to run the project. The design on the base model has no number of rod fins, but this model still can generate more extended surface area to increase the rate of heat transfer across the region of the WCO flow inside the device. As you can see, as the result, the value of WCO after being preheated is 162.20398 degrees Celsius, which is higher than the temperature of 50 degrees Celsius of WCO before being preheated, as shown in figure. So, this is my Gantt chart. For the first week and the second week, I find the supervisor and available topics, attend the seminar 1 and 2. Next, I contact with the supervisor and discuss about the selected topics, registration for the title of final year project, find the article that related to selected topic till week 6, study more about the software, which is NC software. Then I study the methodology. Next, preparation of expected result after finish the software, and prepare for the proposal and logbook. Also correction of the proposal after checked by the supervisor, and lastly the submission of proposal and logbook. That's all from me. Thank you.